Hi guys, today we are going to discuss about insertion sort. So let us discuss what is the algorithm here. So the main theme is inserting the right element at the right place. So what you need to do is you need to pick the element. Let us consider it as our chosen element, and you need to go from index, current index -1 to the left. That means the left side of the chosen element. So what is the condition for loop? The chosen element is smaller than the current element. That means if you choose the current index -1, it should be uh, greater than the chosen element. Keep swapping to the left until the above conditions hold true. So now the first iteration is I is equals to 1 and j is equals to 0. So now if you see in the array I is equals to 1, that means -23. The chosen element is -23 and the current index -1, that is 0, is 200. So we need to swap because this condition holds true. And now the array after the first iteration is this one, and second iteration I is equals to 2 and j is equals to 1. That means I is equals to -123, the element, the chosen element is -123, and the j is equals to 200, which holds the condition for that one, and will swap 200 and -123. And in the later condition also -23 is greater than -123, we'll swap again. So the final array is this one. And the third iteration I is equals to 3, j is equals to 2. That means the chosen element is 1 here, and our current index is 200, which holds our condition, and will swap again. The final array will be -123, -23, 1, 220. Because why don't we swap 1 and -23? Because the condition fails. And in the fourth iteration, I is equals to 4 and j is equals to 3. That means we are choosing 20, and the current index -1 will be 200, and probably we'll swap these two. So I think I wrote something wrong. So we can swap 220, and further going through, we can't swap 20 and 1 because 20 is greater than 1, so which fails the condition there. So that's it, we got the final array, right? It is sorted. So this is the basic algorithm of insertion sort. So let us discuss what is the time complexity here. So this has two conditions. There is the best time complexity and the worst time complexity or average time complexity. So let me tell you in a short way. Best is nothing but when you have the minimal time to run an algorithm. The worst is nothing but what is the at most maximum time an algorithm can take. What is the average? Like it may be sometimes on an average, like you can consider best and worst average. That's it. So let us discuss when we'll have the best time complexity. If the array is sorted, right? If the array is sorted, there are no conditions. Like if we take this condition, like this is a sorted array, and if we pass this into our insertion sort, we'll consider -23 as a chosen index, and our current index -1 to 0 will loop to the left side, right? So -23 is already greater than -123, which fails this condition. We only loop until the chosen element is smaller than the current element. So that means this condition fails. So I increments to forward, that is 1. Again we check the condition, it fails again. We move forward, we move forward, we move forward. So we'll reach the end of the array. That means we only iterated n times, right? So the array is sorted. So then the time complexity will be order of n, because every time the condition fails and will not be looping. Hence only outer loop runs for n times, which is order of n. And what is the worst time complexity? When the array is not sorted, right? So now what happens when the array is not sorted? So the outer loop and the inner loop both iterate, right? So whenever the array is not sorted, we have to iterate to 2 loops. So now when I is equals to 0, j loops for 1 time. Whether if I is equals to 1, j loops for 2 times, and so on. So that means by this we can understand that the loops can be some sort of this thing, like 1 plus 2 plus 3 plus so on n. So this is nothing but n into n plus 1 by 2, which is probably equals to order of n square. So what is the space complexity of this algorithm? It is nothing but we are not declaring any much arrays or 2D arrays or 3D arrays. So that means we only declare the constant variables like left, right, and let I, b, j, like that. So that means we are only declaring constant. So we are only using 2 variables which are just integers. So that means the space complexity is order of 1. We need to declare the outer loop, which is for loop from let I is equals to 1, I is equals to 1, and I less than array dot length, and I plus plus. So now we'll have a chosen element, right? So let chosen element be array of I. This is our chosen element, and now we are comparing this to the left side of the array, right? So we can simply iterate like while. So we can place maybe a variable here like j points to I minus 1, and while j is greater than minus 1, and the chosen element, which is chosen element, we only loop until chosen element is greater than array of I, like array of j, my bad. And what we'll do, we'll just need to swap these two elements. So what need to be swapped? They are array of j and array of j plus 1, and we need to swap with array of j plus 1 comma array of j. So here we can, and we'll decrement the j minus minus. That's it, our algorithm has finished. So let me explain our algorithm in a single line. So here we are looping from I equals to 1 to the end of the array, and inside we are choosing an element. The chosen element is array of I, and we are choosing the elements which are on the left side of the chosen element. That means the j starts from I minus 1. So while j greater than minus 1, and the chosen element must be greater than array of j. I think you understand this, what I am saying about. The chosen element must be greater than the current element. So in that case, we'll try to swap those two elements, and at final the array will be sorted. So we can simply return the array here. So let us check whether this works or not. Node insertion sort. You can see that 221 minus 23 and minus 123, the array is sorted, but it is in reverse order. So what we can do is, we can simply, when the chosen element is less than, this is the right algorithm. So now this happens like minus 123, minus 23, 1 and 20 and 20. So if you want in an ascending order, that means the chosen element, if the chosen element is less than the current element, then we'll move it to the left hand side. That means our left array is sorted in the insertion sort, and the right side of the chosen element is unsorted. So if we want to make an array in ascending order, we can make this condition. If you want to have a descending array, then you can change this condition, which works for both conditions. So probably I think you enjoyed this session. So let's meet in our other session.